Hey there. So this video is going to be about binary arithmetic. So hopefully this video and the next video or the next couple of videos I'll be talking about addition, subtraction, multiplication, and division. So just the four basic arithmetic operations, and we're going to see how you can do this in binary. And it actually it's a lot easier doing these things in binary just because you're only working with two numbers. Your set of numbers is very small, so it actually turns out to be very simple in binary to do these operations. So first off, let's talk about a little bit about the table of operations that we have for uh, for addition. So in binary, we have 0 plus 0 is 0, and we have 0 plus 1 is 1, and 1 plus 0 is 1, and 1 plus 1 is 1, 0. So, or what you can say is, there's a caveat here. It's 0, but then you carry the 1 to the next place. And now, with these rules, literally all you have to do is apply each of these rules to whatever case that you need, and the answer just kind of falls out. And it's, like I said, it's really nice to be able to do that. It makes it a lot easier. So let's say we have 13 in base 10 plus 11 in base 10, and we want to add these together, and in base 10 that equals 24. And so this is kind of a quick way to verify it. If you already know your numbers that you're using, you can go ahead and add them together, and you know your result, and then you can convert. When you get your binary answer, you can convert to base 10 and see if your result is correct. So now we know our sort of end result here that we're working for. Let's go ahead and convert these numbers to their binary equivalents. So in binary it is, let's see, 8 and 4 and 1, that's 13, and 8 and 3. And we want to add these together. So now we're in our first column, 1 plus 1. We go over here, so we have 1 plus 1, and we say it's 0, and then we carry the 1 to the next spot, and now we've got 1 plus 1, which is again the same rule, so we can, let's see, let's just number these rules for quick reference. 1, 2, 3, 4. And so now with rule 4, we get 0 again with 1. And then we say 1 plus 0 again with rule 4 is 0. And carry the 1. Now here's an interesting idea. So now we have 1 plus 1 is 1, carry the 1 over, and this goes away to 0. So now we have 0 plus 1 here, and that gives us 1 by rule 2. And then we move over to this column. We have 1 plus 0 by rule 3, which gives us 1, and in base 2. So if you didn't see that, three ones added together will give you, so 1 plus 1 plus 1 in base 2. These will go to 0, and then that 1 will go to the next spot, and then this 0 plus this 1 will give you, by rule 2 or 3, I guess there's the same, by rule 2 or 3 you'll get 1. So that's what happened here. And then we have, if you want, we can fill out the rest of the numbers like this. Typically you'll see binary numbers written in groups of 4 like this, so with sort of a gap between each group of 4, so you can kind of reference it pretty quickly. So now we can say this is the 16's place. So here the number, the decimal number equivalent is 1 times 10 to the 16 in base 10, and then 1 times 8 base 10. So 16 plus 8 is, you guessed it, 24 base 10. So we know that this matches, and we're good to go. Like I said, what makes it so easy is that you have these sets of rules over here that you can just quickly, you easily remember, and then you just sort of for each column, you just remember the rule that you need, and the answer kind of falls out. So let's do some subtraction. So just like with addition, there are some rules for subtraction as well. So for 0 minus 0, we get 0. And for 0 minus 1, we get 1, but with a caveat. And the caveat is that you need to borrow from the left number, from the leftmost one. And now we can continue, and let me kind of number these a little bit. 1, 2, 3, and 4. And we can say 1 minus 0 is 1, and 1 minus 1 is 0. So now, just like before, it's fairly easy. All you have to do is remember these 4 rules, and the answer just kind of falls out. So if we take, say, 5 base 10 minus 2 base 10, and we get 3 base 10. Now let's convert these to their binary equivalents. We get, let's see, 0, 1, which is 4, 0, and 1. So 4 plus 1 is 5 base 2, and 2 is just 1, 0 base 2. Now we subtract. So for our first case, this first column, we have 1 minus 0, so it's rule 3. So we get 1, right? And then for this next column, we have 0 minus 1, which is 1. And we cancel this guy, and it goes to a 0. And then we have 0, 0, 0 minus 0, 0. And then 0 minus 0 is also 0. So now we're left with 0, 0, 1, 1 base 2, which is 2 plus 1, which is 3. So we know now that this guy and this guy, they match, and we're good to go. So like I said, it's much, much easier. Fewer, I guess, you grew up with, being able to subtract and add, decimal numbers, but I feel like once you kind of get the hang of this, you realize just how easy it is. Like I said, the answers just kind of fall out, and you don't really have to do anything actually. And also, I wanted to mention why we're actually using binary digits. So in this case, we have our set of numbers that we're using for binary base 2 is 0 and 1. So essentially, a computer is just made up of switches. So a switch can be, okay, that's a bad switch. So a switch can be open or off, or the switch can be closed or on. So now we can associate off with 0 and on with 1. And so we have electronic switches. If we configure them in the right way, we can get them to do really nifty, cool things for us at very high speeds. And essentially, they're still manipulating data. That's all they're doing, but at a very high speed, and a lot better than a lot more accurate, and a lot faster than we can. So that's what makes this so useful when designing computers and designing chips and TVs and just anything, all kinds of stuff, your cell phone, and it's based on this fact that everything electronic is built of, or I guess digital electronics is built on either it's a switch, so it can be on or off, and we represent that with a 0 or a 1. And from that, you can kind of understand why we're using base 2 and why we need to understand it a little bit more. So that's it for this video. I hope to see you next time.